This presentation is on the flow of instructions through a PC. It's presentation 2 in the series on how to upgrade a PC. It's best seen on the link in the comments, which will take you to my online PowerPoint presentation on my website. This next part of the presentation is about the flow of instructions from the hard drive, the memory to the processor where it's executed in the PC. So I'll start with talking about an operating systems. Examples of operating systems include Windows 10, 11, 8, 7, Vista, and XP. In a bare-bones PC with an operating system, apps are initially loaded onto the hard drive or solid-state drive where they remain permanently. This can be through downloads or the use of a USB, DVD, or external drive. An example of an app may be Office 2021. So here's a picture of an internal hard drive and a solid state drive. The internal hard drive on the left is 3.5 inches and solid state drive is 2.5 inches. If we want to use an app like Excel, we select it and it's loaded into memory. This is what memory looks like. Memory is typically DDR2, DDR3, DDR4, or DDR5. DDR4 and DDR5 are the most recent fastest, with DDR5 the latest. This is all given the name RAM. This type of memory is smaller but a lot faster than the memory on the hard drive or solid state drive. The hard drive and solid state drive memory is long-term storage. This memory is temporary storage. It doesn't retain its value when the PC is powered off. It's for programs that are currently in operation. The section of an app that's about to be executed by the processor is then taken from the DDR memory or RAM and sent to be processed by the CPU or processor. Code instructions are taken from memory and put through the processor, which it takes to form an action. That's the diagram of a processor just appearing. Actions might include scrolling on an Excel document, writing a value to a cell, or saving the document to the hard drive. Any changes that occur, including some we can't see, are performed by the processor. The processor has its own memory to speed up its operation, or the processor cache. It's super fast, even faster than RAM, but very much smaller. I think from the above we can conclude that an increase in the speed of the processor and the size of the processor cache will improve its performance. An increase in the speed and size of the RAM will also improve its performance. Also, the speed of the hard drive and SSD drive relate to a faster operating PC. On the following presentation, I'll look at some metrics for measuring the processor speed and power, memory speed and effectiveness, and hard drive capacity and speed and lifespan, so that we can tell a powerful component from a weak one, powerful and useful component from a weak one. Well, that's all I have to say in this brief presentation. Thanks for listening.